Hey YouTube, I'm Nick, and today we're going to talk about custom classes in Godot. If you're not using these already, I'll explain some of the value of using them. The point of creating custom classes is that you can slowly build upon previously defined functionality in order to create exactly what you need in a reusable and extendable way. What this means in terms of practical benefits is that you can write code one time and have it impact multiple aspects of your game. You can help organize your thought whenever you're actually defining your systems in your game. You can create more easily extensible code. So as your game increases in complexity, you can essentially stay organized, and if you make a change, it won't break everything else in your game. So this video is really for people who may be newer to coding or are at a point in their project where anytime they change something, it kind of breaks the entire game and they have to go fishing for it. This is a way to help alleviate some of those problems, or just help you build your game in a way that is going to be maintainable from the start. The goal of this is to give you a new tool in your toolbox. This is not the only thing that you should be doing in order to keep your code reusable and extensible. This is just something for you to think about whenever you're deciding on how you'd like to structure your game. What exactly is a custom class? Well, Godot uses a node system, which is essentially an implementation of custom classes already. As you can see here, we have the node tree for character body 2Ds. And what this essentially shows us is that character body 2D is built on top of physics body 2D, is built on top of collision object 2D, and so on and so forth, all the way back down to node. Character body 2D contains all methods and properties of every node underneath of it. So if you create a character body 2D like we have here, you can see that we have a node section here, and it has properties from the node class. And that includes things like the ability to add a script to your character body 2D. For node 2D, we have things like transform, because node 2D is how we place our object into the 2D game world. And we have things like character body 2D, which will allow for things like motion modes, up directions, and basically every other functionality that comes along with being a character body 2D. Now, what I'm going to explain to you is that we can actually build on top of that in a way that is reusable. Since these are all built on top of each other in this way, it only makes sense that we could continue to build on top of each other even further in a way that is reusable. In the same way that you can use a character body 2D in many places in your game, you could also use a custom class in many places in your game. A good way to think about this is, in what way would we extend this in order to create something useful? Let's say that our end goal is to create a player for our game. We have our character body, and character body is built on top of, for instance, node 2D and node, but how would we eventually get to define a player? And in what ways could we generalize code away from the player? That way we're only defining what we need to in our player script. Well, we could create something called an entity class, which we will be able to reuse in other places in our game. For instance, if we have an entity that is an NPC or an entity that is an enemy. A lot of the methods and properties that a player contains, an NPC or enemy might also need. And so we can try to draw everything out of player and put it into entity. That way we only have to write it one time, and it can apply to players, NPCs, and enemies. You may realize at this point that this triangle is really not that good of a way to describe this, because the way that it actually works in Godot is that it's more of a tree. You can see that node is built on top of by all of these things, and node 2D is built on top of by all of these things, and every single one of these is essentially their own pyramid to get to you exactly the functionality that you need in a reusable way without packaging anything that you don't need. Because if you are trying to load in all of these things but you're not going to use any of them, then it's kind of a waste of resources to even have these things defined. So let's say that we have our base of entity right here, and then we have our player, we might have our NPC, and then we'll have our enemies, and they'll all be built on top of the entity class. And what might the entity class have? Well, we know that all players, NPCs, and enemies are going to have, for instance, a texture because they're going to show up in game and be visible. Maybe all of these things will be able to take damage and die or have like some type of health system. You don't need to go and implement these in a custom way for every single class, and that's kind of the idea of building these in a generalized way so that your health works in a consistent way across the entire game and you only need to define it one time. Now we could also talk about what are things that will be different among these. Well, maybe player has a movement, and maybe enemies also have a movement, and maybe NPCs have conditional movement as well if, say, some sort of effect were to happen to them, but they're all defined differently. Well, actually what you can do is you can create movement in here and you can overload it in each of your subclasses to work differently. And this is an object-oriented programming concept called polymorphism. And the idea is basically you're defining things here, but your children can implement these things in a different way. Let's go ahead and teach you a practical example of how you would actually implement this. Here we are, we're in Godot. We'll go ahead and delete this character body 2D, we'll create a 2D scene, and we'll create a level for our characters to play in, and then we'll create a sprite so that we have some kind of background. We'll load in this, and this will just be our background so we can see what's moving. Go ahead and stretch that, it'll be really big Godot symbol. Now we'll go ahead and we'll create that character, body 2D, that we did before, and our character is going to need a sprite so that we can actually see it on the page, and then we will add a camera as well so that we can actually see our player as it moves around. So we'll quickly load in, here's our character, here's our camera, here's our character body 2D. I'll go ahead, we'll name this player, and we'll create a script. Now our player is created, it's extending character body 2D, and we have some basic movement. I'd like to imagine that this is a top-down 2D game, so I don't want to have jumping, just because I think it makes our example a little bit simpler. So we'll go ahead and update this. So what I just did is I updated this so that we get 2 axes of movement with the getVector method. By the way, if you control click on almost anything in the game or in the script editor, you can see its definition in the documents. So here, if we go down, what we're looking for is getVector. I can click on that and it'll show you basically a description of it as well as how to use it. These are all the inputs that you want, and this is what it will return. This is going to output a vector2, which is essentially just a 2D plane with up and down value and left and right value. And then if we fill that up with some type of input, so if there is an input and it's one of these things, then we'll have our variable direction, and our direction will then be multiplied by our speed, and that's how we'll get our character's velocity. If there is no input, then we just want our character to stop, and that's what we've got right here. Boom. So we'll also go into here because I like to move with WASD, and we have the need to update these. So UI left, so that's our left, will be A, UI right will be D, UI up will be W, and UI down will be S. So now all of these are defined, and we go ahead and save this as our level scene, and our script gets saved. Now if I click play and we select our current scene as our default, we should be able to see that our character is able to move. Boom. Let's go ahead and explain how to actually implement a custom class in script. So what we're going to do is we'll create a new script and we'll call this entity.gd. We'll go ahead and open that, and you can see here that this extends node, but we actually want our entity to be built on top of character body 2D. So boom, now this has everything that a character body 2D would have, just like we have here. And let's say that what we want to define is everything that we just defined in player 2D or in our player script. So we could go over here and just paste that in, And I forgot to grab this constant. Boom. So now you can see that our entity contains everything that player used to, and player now contains nothing. If I click play, our character is not able to move. You hear me clicking buttons, nothing happens. What we're now going to do is implement our class. So if our class name is entity, now we have a custom class called entity. And now instead of extending character body 2D, if we extend entity, now everything defined in here will be captured in our player. So now we are able to move again. And we can further extend this by adding script in our new child class. So now our entity contains everything that we defined here as well as everything in a character body 2D. So we have a custom class that is built on top of character body 2D. So it not only contains what we defined here, but it also contains everything inside of character body 2D. And so that is what class name entity is. So whenever we extend our entity, that contains everything defined here as well as everything in character body 2D. If we want to continue to extend that, we can do that right here. I'll explain to you the idea that we are talking about here with the movement morphism. Let's pretend that we want this to work a little bit differently. What we'll do is we'll take the exact same function and we will define it differently. Let's say instead of what we have here, we just want to change it to move down when I press up and up when I press down, as an example. There we go. Now, if I go into game, whenever I press up, I move down. Whenever I press down, I move up. When I press left, I move left. When I press right, I move right. So now our control scheme is different. Even though we're extending entity, we've redefined the exact same function, and that is polymorphism. Something that can be useful if we want to do polymorphism but keep this all the same is we can use this term super. And what that means is it takes super delta, because this function in entity requires an input of delta. And here's our delta right here. What this super does right here is it basically copy pastes everything here right here. So say we have everything here that we want to do, and then do something else on top of that. Like, for instance, every physics frame, we'd like to print hello world. So now what we can expect to happen is every single time physics is rendered in the game, our movement will still work, but we will also be printing hello world down here. So if we go ahead and click play, you can see we're printing hello world down here, and we still have movement. And you see we got 425 hello worlds in that short span of time. This is also polymorphism because we're taking a previously defined way of doing things and then we're extending further upon it. Cool. So I think you get that. So you can use this basically for anything. You don't need to do it for movement. You could do it, for instance, for items. Say that you have an item system in your game and it's built on top of Node 2Ds. You might have items that you can pick up that are weapons. You might have items that you can pick up are passive effects for your characters. You might have active items that you can pick up, like say a grenade or something. You can define all of these to have a base item class, which will allow for functionality like, say, picking them up, but you can have subclasses that define what they do once you actually pick them up. So a weapon may contain information about its damage, how it shoots, things like that. A passive item may contain script for how you're updating the character once it's picked up. So say it does like a passive speed increase or makes you do more damage. You can also implement something like a passive item where once you pick it up, maybe it goes into your inventory, and then once it's selected, you can throw your grenade or hold it, or, you know, whatever your active item maybe does. But these can all be built on top of the base of an item class, and you can have things like the pickup defined there so that you don't have to define it for each and every single one of those items. So we've talked a little bit about how our player, which extends entity, contains everything defined in entity, and since our entity extends character body 2D, that contains everything in character body 2D. This is a concept in object-oriented programming called inheritance. If you're curious to learn more about it, that is a good term for you to search. We're going to talk about another object-oriented programming concept called abstraction. The idea is that you want to hide detail whenever it is prudent. So basically, you don't want your player to be defining more than it has to. You'd like to ideally abstract things out, and your player doesn't need to have any idea how this is implemented. It just needs to know that it is. So your entity class may contain your health system. Your player has a health system, but your player does not know anything about how the health system works. It just knows that it has it. That's kind of the basic idea of abstraction. Another way to think about this is, say your entity class knows that all entities will contain a move, but you know that each individual class is going to define its move on its own. Well, what you could do is you could define a move function. So say we have here function move. This can be defined somewhere else. We know that every entity is going to be able to move, but we know that every entity is going to define move in its own way. Let's say, for instance, we know that our physics process, what we're going to want to do is move. And then in our player class, we don't need to redefine our physics process because move is already being called. What we can do is update our move method with everything here. So now, whenever we play this, our entity knows that it has a move function and goes ahead and calls it, but our player actually defines the implementation of move. So if we go ahead and click play, our character is able to move in exactly the same way. And so that's abstraction. Our entity knows it must move and calls move, but our player is where we actually define how move is implemented, because that's where the responsibility should lie. So what you might be thinking after seeing how we implemented this is, well, if we're defining all of these methods but not actually filling them out, what we're actually creating is a bunch of code bloat, and it may be hard to actually find where something is to update it. And to that I'd say, you're probably right. So I want to explain to you a little bit about a good way to navigate your code. What I told you earlier is that you can control-click things in Godot and it will bring up the docs for it. What you can also do is control-click on custom things that you generate, and what that will do is it'll take you to where it was originally defined. So we're in our player script right now. If we go ahead and control click on entity, then that will take us where our entity class was defined. In the same way, say that we wanted to see where move was defined, we'd go ahead and control click on that, and here's the first use of move. That is just a good way of navigating your code and being able to keep track of where things are defined. So now what I want to talk to you a bit about is how can we implement this further than just in code. So what you've seen so far is that we created an entity script, but our entity script is not really attached to any kind of node, so it just kind of exists in our file system. How would we go ahead and implement an entity if we wanted to do that in our node tree? What we can do is we can go to here. So what you'll see is if we navigate our node tree down to character body 2D, we actually have a new class called entity, and we can actually create a new node called entity, and that comes default attached with the entity script, which is great. So we now have an entity node that we can place in our scene tree. So let's talk a little bit about how we would use these custom classes in Godot in a more practical way. Let's think about maybe creating a scene for our entity. So what we can do here is we can right click and then we'll save this branch as scene, and we'll call this entity. And now it's its own scene, so we can click on this and go to here. And this is no longer going to be our player. We'll call it entity. So we'll call it entity, and entities don't need a camera. What we can see here is that we still have our player script attached to our entity, but this is now our entity scene. So we'll go ahead and attach our entity script. Every entity will contain a sprite now and not a camera, because we may in the future have things like NPCs or enemies, and they don't need the camera to be following them. We want the camera to always be following the player. Let's go ahead and take this simple scene and extend it to have a player scene, which we can then put into our level, because currently we just have our entity. So we'll go ahead and we'll right click in the file manager on our entity scene, and we'll create a new inherited scene. You'll see that this turns yellow, and we have something called entity here. This is going to be our player scene, so I'll go ahead and I'll call this player, and this comes already attached with the entity script, but we're going to replace that with the player script, and we'll go ahead and save this as the player scene. So now we have a player, which is a child of entity. Our player, we're going to want to have a camera on, and that makes it now have polymorphism from our entity scene, because we have everything from our entity scene. So we went ahead and added a camera to our player scene, and what that does is it extends our functionality beyond what our base entity can do, since we want the player to be the one that the camera is focused on, not enemies and not NPCs. And what you can see is if we go back to our entity scene, we can edit this and it will impact the player too. Let's say that we create a node 2D, and we'll just call it our health system. We're not going to actually implement this, but this is just to kind of show a point. If I go ahead and save that, we now have health system as part of the entity. If we go back over here, boom, health system is now implemented into our player scene as well. That just means that once we edit our entity, all child scenes will be updated as well, which is a really nice feature to have, because it means that you can edit things in one place and it can impact your entire game. Let's go ahead and prove that everything works the way that it should in the game. We'll go ahead and we'll delete that entity, and we will drag our player scene into our node tree. So now we have our player in here, and if we click play, it should work the exact same way as it did earlier. You'll see that our character can move just as it should. And now I'll show that we can create a new scene of entity, and we'll call it enemy. So we'll go ahead and create a new inherited scene off of entity. We'll call this one enemy. It contains everything that's sprite and health system, just like entity has, and it will not have a camera as player does. We're going to go ahead and call this scene enemy. Currently it has the entity script attached, but we'll go ahead and we'll create a new one. Instead of extending character body 2D, we're going to extend entity, and we'll go ahead and create that. We'll get rid of everything that gets auto-loaded into here, and we will, as we did in player, update this move function. Instead of getting an input vector of left, right, up, and down, let's just do this. So we'll say 0, 0. Oh, that's supposed to be a string name. That's unfortunate. Here, what we'll do is we'll do get axis. And then we'll say velocity.x. So we've gone ahead and we edited how the movement works for our enemy, and it's going to be based on our input still. This isn't how you do it in an actual game. You would implement some kind of AI movement, but for the sake of simplicity and to show what's going on, we're going to do it like this. So what we're going to expect to happen is anytime I push left, the enemy will move left. Anytime I push right, the enemy will move right. Anytime I push up or down, the enemy will do nothing, but our player will move up and down. Let's go ahead and place an enemy into our level, enemy scene into our level. We'll go to here and make sure to move the enemy. So here's our enemy, and it will be right here. And now if we go ahead and click play, you see that whenever I move right, so does the enemy. Whenever I move left, so does the enemy. Whenever I move up and down though, the enemy stays still. So I can move up, move right, and the enemy will follow us, and boom. That's how we can go ahead and overload movement in different ways for different scenes across different scripts. And they both extend entity, and they update this move method differently. That's about all that I wanted to show you. What you learned today was how to implement a custom class in Godot, some of the values of it, how to avoid some of the pitfalls, and some basic examples of how to implement it. So I hope that you can see that if you were to just spam this throughout your game, you would end up with a web that's very hard to maintain. But whenever you're defining your basic game, you can think of these structures that you would want to build in order to stay organized as you go throughout the life cycle of your game. I hope you have a good day and you learned a lot.